Professor Brian Cox once said something that stopped people cold. He said that even if we somehow figured out how to travel to another galaxy, the real problem would not be getting there. The real problem would be coming back. Because by the time you returned to Earth, Earth might not exist anymore. Let that sit for a second. Not a metaphor. Not science fiction, actual physics. And today we are going to break down exactly why he said that. What intergalactic travel actually means, what scientists have proven about it, and whether humanity will ever truly reach beyond our own galaxy. Because the answer is both more hopeful and more terrifying than you think. Let us start with the basics. Our galaxy is called the Milky Way. It contains over 200 billion stars. It is roughly 100,000 light-years across. 1 light-year is the distance light travels in a single year. Light moves at 300,000 kilometers per second. So 1 light-year is about 9.46 trillion kilometers. And our galaxy alone is 100,000 of those. Now, intergalactic travel does not mean traveling across our galaxy. It means going beyond it entirely, to another galaxy. The closest galaxy to us is the Andromeda Galaxy. It is 2.537 million light-years away. Not 2 million kilometers, not 2 million miles, 2 million light-years. Meaning even if you travelled at the speed of light, which is physically impossible for anything with mass, it would still take 2.537 million years to get there. To put that in perspective, 2.537 million years ago, humans did not exist. We were still evolving from early primates in Africa. So the distance alone seems to make intergalactic travel completely impossible. But here is where physics gets strange.
And this is exactly what Brian Cox was talking about. Einstein's theory of special relativity tells us something deeply unsettling about space and time. Time is not fixed. It does not pass at the same rate for everyone. The faster you move through space, the slower time passes for you. This is called time dilation, and it is not theoretical. It is proven. We have measured it with atomic clocks on aircraft and satellites. GPS satellites have to account for time dilation every single day, or they would give you wrong directions. Now, apply that to intergalactic travel. If a spacecraft could accelerate to 99.9999% the speed of light, which is still below the universal speed limit, something extraordinary happens. For the people on board the ship, time slows down dramatically. A journey that takes 2.537 million years in Earth's time frame might only feel like 50 to 100 years to the crew. Scientists at PBS NOVA confirmed this through mathematical modeling. At sufficient velocity, intergalactic travel to Andromeda is theoretically survivable within a human lifetime. The travelers would arrive. They would be old, but alive. But here is the part that changes everything.
When they turned around and came back, doing the same journey in reverse, 5 million years would have passed on Earth. Not 5 million days, 5 million years. Every person they ever knew, gone. Every civilization, gone. Possibly Earth itself, gone. The Sun has about 5 billion years of life left in it, so Earth would technically still exist on their return.
but nothing they recognized would remain. No buildings, no history, no record that they ever left. They would return as strangers to a planet that had completely forgotten them. And they would have nobody to tell what they saw. That is what Brian Cox meant. The problem with intergalactic travel is not just getting there. It is the impossibility of return, meaning anything. So what are scientists actually doing about this? Subscribe now to know in the next video.